So let me go back to slide 1. This is what we did yesterday, and this is on yesterday's video. We were counting atoms for each one of these formulas, but we put all of these formulas into a giant chemical equation. So remember, these are the reactant side. This is what we start with. This is what is going to react. This arrow is the yield sign. It means equals or creates our products. So the right side are our products. Reactants, products, okay? All right, so the first thing we do when we read a chemical equation is we're going to record the elements that we see listed by counting the capital letters or identifying the capital letters. So I see a capital K, I see a capital O, a capital H, and a capital P. Okay? Now, this is my reactant side, so this is the only side I'm looking at right now. Okay? I need to calculate the number of atoms of potassium on the reactant side. I have a coefficient of 3, which is going to distribute to each element that it's in front of. Okay? So this 3 distributes to this chemical formula. Okay? This plus sign separates these two formulas. So this 3 does not apply to the HPO. It only applies to KOH. And this tells me that I have 3 atoms of potassium, 3 atoms of oxygen, and 3 atoms of hydrogen. I have a subscript of 5 right here by this hydrogen, so that means there's 5 more atoms of hydrogen on the reactant side. I have a P. It has no subscript and no coefficient, so there's just 1 atom of phosphorus. And then oxygen has a subscript of 4, so that means I have 4 more atoms of oxygen. Okay? So that's the atoms on our reactant side. Now we're going to determine the number of atoms for the product side. For potassium, there's a subscript of 3, so that means I have 3 atoms. For phosphorus, there's no subscript, so it means there's 1 atom. And for oxygen, there is a subscript of 3. Okay? Hydrogen, there's a coefficient of 3 and a subscript of 2, so I need to distribute this 3 to both elements and multiply. 3 times 2 gives me 6. And then 3 times 1 of oxygen gives me 3 more atoms of oxygen. Okay, so my question to you now is this equation balanced? Are the number of atoms on the reactant side equal to the number of atoms on the product side? Did this equation meet the law of conservation of mass? No, it did not. Mass cannot be created or destroyed, so the number of atoms on both sides of the equation needs to be equal. Okay, so for those of you who haven't joined us yet, let me go back and show you a balanced equation. If you look at this equation, there's 4 atoms of iron on the reactant side and the product side. There's 4 atoms of sulfur on the reactant side and the product side. And there's 14 atoms of oxygen on the reactant side and 14 atoms of oxygen on the product side. So there's an equal number of atoms on both sides of the equation. We do not create or destroy mass. We don't create or destroy atoms. We just rearrange them. So the same numbers on both sides, they were just rearranged in a reaction. Okay? Okay. My next example, I need to identify what the elements are. So I have Ti, I have Cl, I have H, and I have an O. Okay, now I'm going to determine the number of atoms for each element on my reactant side, which is the left side of the arrow. There's no coefficient and no subscript for Ti, so there's 1 atom. Chlorine has a subscript of 4, so there are 4 atoms. H2O, I have 2 molecules of H2O, so I need to distribute this 2 to both elements. That tells me I have 4 atoms of hydrogen, 2 times 2, and 2 atoms of oxygen. So I'm complete with the reactant side. Now I'm going to do the product side. Again, 1 atom of Ti. The subscript of oxygen tells me there are 2 atoms of oxygen. I distribute this 4 to hydrogen and chlorine because it's telling me I have 4 groups of this compound, 4 atoms of chlorine and 4 atoms of oxygen. Is this equation balanced? So this equation is balanced. There are an equal number of atoms for each element on both sides. And you can see that in this table. Ti has 1 atom on the reactants and product side. Chlorine has 4 atoms on both sides. Hydrogen has 4 atoms on both sides. And oxygen has 2 atoms on both sides. I'm going to do another example. Okay, I'm going to just write my elements first. I have K, capital K, which is potassium. I have an N for nitrogen. That's a terrible N. I have an O. I have an H. And I have a C. Notice, guys, that I know that there's an oxygen here and an oxygen here. I don't write it 2 times. I only write it once. All right, so let's distribute our coefficient. This is saying that there are 3 groups or 3 molecules of potassium nitrate, I think. There's 3 groups or 3 molecules of this compound. So I need to distribute this 3 to each element. This 3 means that there are 3 atoms of potassium, 3 atoms of nitrogen, and 3 atoms of oxygen. Now there's no coefficient for this compound, but hydrogen has a subscript of 2, so that tells me there are 2 atoms of hydrogen. Carbon has no subscript, so that tells me there is 1 atom of carbon. And then in this compound, I have 3 more atoms of oxygen according to that subscript. And so I'm just going to add that to where oxygen is. Now I'm going to do the same thing, but on the right side for my products. Potassium has 2 atoms. Carbon has 1 atom. Oxygen has 2 atoms. I have a coefficient, so I need to distribute it to each element. Hydrogen has 2 atoms. Nitrogen has 2 atoms. 2 times 3, oxygen has 6 more atoms on the product side. Is this equation balanced? Is this equation balanced? Okay, this equation is not balanced. There's not an equal number of atoms on both sides. My reactants for potassium have 3 atoms of potassium, but 2 on the product. So that means we lost an atom, which is not possible. So this is not right. Then it also says there's 3 atoms of nitrogen on the reactant side. So it's saying we started with 3 atoms of nitrogen, but we ended with 2 atoms of nitrogen, and that again is not possible. So that's not balanced. So this equation is not correct. The law of conservation of mass has not been met because we have lost atoms, okay, and that doesn't happen. With oxygen, it seems that we gained atoms. We have a total of 6 on the reactant side, but we have 8 on the product side. So we gained 2 atoms of oxygen, and that again, that's not possible. Mass cannot be created or destroyed. And anything that has mass and takes up space, so atoms have mass and they take up space. So when we're counting atoms, we're identifying the mass. Okay? So this equation is unbalanced. So I wanted to show you a more complex equation where there's parentheses and a coefficient, and you have to do a lot of distributing. Okay? So again, my first step is to write down the elements that are involved in this chemical reaction. We have iron, we have hydrogen, we have carbon, and we have oxygen. Okay? Iron, hydrogen, carbon, oxygen. Now notice, in this chemical formula, we have hydrogen twice. Okay? So I'm going to combine those. You can add them up however you want, but they both have to be accounted for. I have 2 molecules of iron. Okay? I need to distribute this 6 to this entire formula. Okay? So 6 to this H, 6 to the carbon, 6 to this hydrogen, and 6 multiplied to this oxygen. So I have 6 atoms of hydrogen and with that first H. 6 times carbon's subscript of 2 tells me I have 12 total atoms of carbon. 6 times this hydrogen's 3 is 18. Okay, so I have 18 more atoms of hydrogen in this formula. Okay, so there's 6 atoms of hydrogen here and then 18 here. And then 6 times oxygen's 2 tells me that there are 12 atoms of oxygen. Okay, so now on the reactant side, the total number of hydrogen atoms that I have is 24. Okay, now I'm going to do my product side. Okay, so this side's done. Now I got to do the right side. I need to distribute this coefficient to everything in this formula. So iron, oh, back up. I have parentheses. Let me get rid of my parentheses first. I would rewrite this, but it's really hard to do with this app. So distribute your subscript to everything inside the parentheses. Okay? So there are 4 carbon atoms here. 3 times 2, there are 6 hydrogen atoms here. And then 2 times 2, there are 4 oxygen atoms here. Okay, so now that I've distributed this subscript to everything inside the parentheses, Now I can distribute my coefficient. So I give 2 to iron, 2 to carbon, 2 to hydrogen, and I give 2 to oxygen. Okay? So iron has 2 total atoms. Carbon has 2 times 4, 8 total atoms. Hydrogen has 2 times 6, 12 total atoms. And then oxygen has 2 times 4, 8 total atoms. Okay, and then I have this coefficient to distribute to this subscript. So hydrogen also has 6 more atoms on the product side, and this equals 18. Is this equation balanced? I have 2 atoms of iron on both sides, but I have 24 atoms of hydrogen on the reactant side and 18 atoms of hydrogen on the product side. So that's not balanced. I have 12 atoms of carbon on my reactant side and 8 atoms of carbon on my product side. Okay, so this equation is unbalanced, guys.